Hello, welcome again. We are starting the subject compressible flow, and first of all, there is introduction part, and in the introduction part, there is definition of compressible flow. So, generally, the compressible flow is defined as a variable density flow, but actually, this definition is not complete. The exact definition of compressible flow or compressibility is fractional change of volume with respect to pressure. Negative of fractional change of volume with respect to pressure is your compressibility. Okay. So when this fractional change in volume takes place at constant temperature, then it is called isothermal compressibility. And when this fractional change in volume with respect to pressure takes place at constant entropy, then it is isentropic compressibility. So here these are the definitions of different type of compressibility, and I will read out this. The compressible flow is routinely defined as variable density flow, but this definition requires more elaboration. Consider a small element of fluid volume V. The pressure exerted on the sides of the element by neighboring fluid is P. Assume that the pressure is now increased by infinitesimal amount dP. The volume of the element will be correspondingly compressed by amount dV. Since the volume is reduced by dV, which is negative quantity, the compressibility of fluid is defined as negative 1 by V dV by dt. So this is negative, that's why we have introduced a sign of negative to make the compressibility as positive. So this is the basic definition of compressibility. So physically the compressibility is frictional change. dV by V is your frictional change in volume of fluid element per unit change in pressure. Okay. So next is your isothermal compressibility. When a gas is compressed, its temperature tends to increase depending on the amount of heat transferred into or out of the gas to the boundaries of the system. Therefore, if the temperature of the fluid is held constant due to some heat transfer mechanism, then the isothermal compressibility is defined as tau T is equal to minus 1 by V dV by dt at constant temperature. Curly V by curly T at constant temperature. Because now one thing is constant, that is T, so that way we use curly. So here when the temperature is constant, we are allowing the heat to transfer so that the constant temperature can be maintained in the fluid. So that's why the term isothermal compressibility is defined. Okay. So when we do not allow the heat to take in or out of the system, then the isentropic compressibility is defined. On the other hand, no heat is added or taken away from the fluid element. If if the compression is adiabatic, if we do the adiabatic compression, then there will be no heat taken in or out of the system. And if no other dissipative transport mechanisms such as viscosity and diffusion are important, and we are neglecting the viscosity and diffusion terms, if compression is reversible, we are assuming that the compression is reversible and there is no heat transfer, okay, so that it will make isentropic compression. Then the compression of fluid element takes place isentropically, and isentropic compressibility is defined as tau s is equal to minus 1 by V curly V by curly P at constant entropy. So this is your third equation. First equation is general definition of compressibility. Second is isothermal compressibility, and third one is your isentropic compressibility.